Hello, this is another image processing tutorial for Pixinsight. This video was suggested by a viewer, Mr. Valdemar Witt, hope I'm pronouncing that correctly, who said a similar video on processing galaxies with strong hydrogen alpha signals would be really useful. Now, I assume when you say that you mean images where the galaxies themselves have strong hydrogen alpha regions within them, as opposed to an image with galaxies where there is hydrogen alpha in the surrounding background. The latter case would be covered by the video that you commented on, which is the one of the Cocoon Nebula, whereas the former is what we're about to cover now. This is actually the first time I've done a video based off of a viewer suggestion, and also the first time that I have used a webcam. I noticed that ice cream recorder's options seem to have updated so that I can actually use it. I figured since I have it, why not? You might have a chance to see a kitty, and since I love seeing kitties randomly appear in other people's videos, I figured why not? One of the three of them might make a guest appearance here at some point. So first off, open up our masters. Got my notes up here on my other monitor, so that way I don't forget something. All right, first things first. So our identifiers are for red, L for luminance, G for green, not HG, G, and blue for blue. This is so that various processes that require an identifier, like LRGB combination or RGB combination or L addition, know which images to use without actually having to manually select them, which is far more of a pain in the butt than actually just setting them ahead of time. So I like to do it that way. Okay, we're going to do our image container. Select all. Okay, and we have that set. The first thing that we're going to do is we're going to rotate all of these images. So do our Control A, Control A, Control A, and Control A. And one thing you may notice is that there's a lot of black around the outer edges of these images. The reason for that is I had some hydrogen alpha data that was taken at a bit of a different field of view or different direction. And so when I stacked them all together, it expanded each image so that way they could all overlap. But I'm not using the hydrogen alpha, so it doesn't matter. When I get a little nitpicky, we can notice that these stars are not completely vertical. And if you are in a competitive environment, such as Astrobin, little touches like that I think can help. It certainly doesn't hurt. So the first thing we're going to do is go to Process, Geometry, Rotation. And want to hone in on a star, so Alt-N to do a new preview. Get one of these bright stars with some spikes on it to create a preview off of it, and we want to rotate this counterclockwise. So we're going to change this to, let's say, 3 degrees, and drag it over, and oh, you can't do that. It's a preview. Oh, now what do we do? Well, the answer is very simple. Grab this preview, drag it off, and it'll create a new copy of the image based off of that preview. And now, when we drag our triangle onto the image, hey, it works. I want to zoom in on this a little bit, hit Alt-N. At least this is how I do it. If somebody knows of an easier way to go about this whole process, please let me know, because this is a bit of a pain and it's tedious. Alt-N for a new preview. Go right in the middle of this spike. Drag down, and that is darn close. It's not 100%, but it's darn close. That's a great first try. Gonna get rid of this preview. So it was slightly under rotated. So it needs to go maybe 0.1 degrees further. So we're gonna undo rotation. We're gonna go 3.1. Do it again. Alt-N. Right in the middle of this thing, drag it down. Actually, that's too much. My brain is working backwards today for some reason. But that's what happens. You get to see me screw up. That's okay. Undo. So we're going to go from that to 2.9. Drag it over. Alt N. Get in the middle. Drag down. And that's pretty darn close. Normally I would call that good, but just for giggles, let's go to 2.8. Oops, helps if you undo it first. And that's pretty darn close to perfect. I like that. That's good enough for me. So we're going to close all this out. You don't want to save any of that. We don't care. Close this one out because we don't need it. And drag the corner of our image container down to the bottom of the rotation window. Okay, we can close that. And now to do a crops. So we're not operating on these blackened out edges of our images because we don't need all that stuff. Crop, left click and drag so we can get a hold of the edge. Drag it down so we can actually start working with it. And bring it back up. That's about right. It doesn't have to be exact. I will crop in closer on the Galaxy later. The reason why I'm just doing this for now is A, to get rid of all the edge artifacts and all this black, and also so that when we do spectrophotometric color calibration, we have a larger population of stars to sample from. Take the dynamic crop, the triangle, drag it down onto the desktop so we save a copy of this process, close out the one that's active, take our triangle and drag it to the copy that we just made. All right, next step is to do a blur exterminator correct only. For those of you that don't remember or don't know, you open up blur exterminator and you check correct only. What this is going to do is it's going to correct the star shapes on all of your images. I've watched videos where they discuss specifically doing this on your separate masters because sometimes, especially when you're using separate RGB filters like I am, the angle of your camera, the collimation of your telescope, your tilt, little things like that will change even during a single imaging session, but definitely between nights. And because of that, especially if you're not constantly rotating through all your filters, maybe you're doing red all in one night, blue all in one night, something like that. There will be differences between your filters, and even just little variations in how your filter is sitting in your filter will can even make a little bit of an effect, although it's not much. But the point being that the star shapes in each of your filters are going to be subtly different, so it's better to correct them individually. Now I have hardware acceleration enabled on my computer, which makes this process much, much faster than it would normally be. Instead of taking, say, 15 minutes for all four masters combined, it only takes a couple of minutes, something like that. So if you can do hardware acceleration, I highly recommend it. You do need an NVIDIA GPU to be able to do it. In fact, I switched from a Radeon GPU to an NVIDIA GPU just so I would be able to do this, and it saves a lot of time. It's very, very nice. All right, on to number 4. After this is done, I'm going to do a blind Graxpert. And my reasoning for it is as follows. We have a relatively isolated subject in the center of the field with basically the rest of the image being background. That's the kind of thing that Graxpert is usually very good at dealing with. If you have a full screen subject, like you're taking a full frame image of, I don't know, some dark nebulae, some of the more extensive dark nebulae, or something like the question mark nebula, something like that, where it's just a very large object and you can't get it all into your frame with most setups. In that situation, it's almost always better to use DBE, but for something like this, you don't really need it. Graxpert does a perfectly fine job for subjects like this, so that's where I'm going to use it. You, of course, want to verify that the whatever it has extracted, it looks reasonable. And you do that by making sure that you have it display to the background image that's been removed as a separate image. You can do Graxpert on your combined RGB image after combination. I don't. Um, I could see that one going either way, but I just generally do it on the separate masters. I don't think there's anything wrong with doing it on combined RGB. I think it does a perfectly fine job. Blue looks a little strange, but there's nothing really to be worried about. That's a more normal look. Luminance looks fine. And the one that, pretty much the only one that really matters here is our luminance. It is annoying if you have some color gradients in your RGB, but there's other ways to fix that. Whereas if your luminance has gradients in it, that's much more difficult to deal with. So that looks fine. That looks fine. That's a little weird, but it's fine. And this is kind of strange, but it's okay. All right, so now it's time to combine our red, green, and blue. Hit the circle button for this one. Pixinsight is not always entirely consistent, at least I don't think it is, so you just have to memorize which one's which sometimes. Immediately, we're going to rename this to RGB, because that's what it is, and do a new screen stretch on it. Actually, we can get rid of this, and that doesn't look too bad. It's a little bluish looking, but it looks like a perfectly reasonable image to me. Don't see any major problems with it. There's a little bit of subtle red to blue to red, sort of large scale, like on the order of maybe the size of my thumb, modeling the background, but that's very, very normal and expected from RGB imaging, especially when you don't have integration time on the order of like 30, 40, 50 hours. That's completely normal and it's not that hard to deal with. But the subject itself looks perfectly fine, and we can see some of these little hydrogen alpha areas in here. Even without enhancing the saturation on this, they are readily apparent. So now's the time to do our plate solving. Because we cropped this, we're going to have to redo the plate solve. So go to script, astrometry, image solver, change our year to 2026 because that's what the year this is. You just have to be within a year. You don't have to get super, you don't have to give it the month and the day or anything like that. It's fine. I'm going to search for M51, hit enter. Just accept that result, that's fine. Double check that your focal length and your pixel scale are correct, and then hit OK. I heard some growling from cats a little while ago, and I turned to see that the usual troublemaker has actually been sleeping in the corner over there out of frame for at least the past 20 minutes, so it couldn't have been him. All right, we've reached convergence, so it'll give us our final plate self soon. Ish. There we go. Okay, so I have this spectrophotometric color calibration set up for my actual chip and my actual filters. You can pick just about any filter as long as it's RGB and that's what you're actually using, and you will get a acceptable result. I just happen to have mine in here, so I use that. But you could probably use Chrome. I actually have used data from Chroma filters with this setup, and it comes out just fine. You just got to give it something. Now we're going to correct the color in our image. It's already pretty good, which is surprising. Most of the time there's a bit of a green cast, but this time it's not so bad. And what we want to see is a nice tight grouping around the sloping line. And that is in fact what we see. All of our stars are pretty darn close to our line, which means we have a good color collection. Get rid of that, get rid of that, hit F12 to reset the screen stretch, Control A to apply a different screen stretch, and now we have a much more neutral looking background. It doesn't look blue anymore, it looks fairly gray with some color modeling in it. And I think that's a perfectly acceptable result. I like it. So we can now minimize our green, our blue, our red. Should get this out of the way at the same time too for a moment. And get these out of the way for now because we're done with these just for the moment. Actually, we don't need the luminance right now. We don't need that at the moment. Our image container needs to be updated. We can see, disable this item. Let's see, delete item, that works. Get rid of the R, get rid of the G, get rid of the B, select some new ones, get our RGB selected and re-add it. So now we're only applying stuff to the luminance and the RGB from now on when we use our image container. Okay, so let's do our actual crop for subject. Reopen dynamic crop, drag it over a bit, grab the corner, and I would like for this little baby galaxy down here, just a little bit of added interest, and then get it more or less cropped in as tight as we can other than that. I usually try to go for about a 3 to 4 aspect ratio. That is 3 units of width and 4 units of width and 3 units of height. And basically want to be centered on the center of this galaxy. So we got our height. We still have this little baby galaxy in there. And then to get a 3 to 4 aspect ratio, my width, actually, sorry, my height is 2524. We'll just change this to 2500. Shift tab to go up. Make sure that my headset doesn't turn itself off, which it loves to do. I actually just wasted an hour doing my last version of this video because I realized I didn't have my headset on the whole time. It turns itself off. How nice. Technology is wonderful sometimes. Times 4 divided by 3, we get 3,333. I think I'll just round that off to 3,400. That's fine. So we'll make this 3400, enter. And now we have our aspect ratio and our crop set. Drag the triangle down to the desktop, close the active version of dynamic crop. Yes, I don't care. Get our image container, drag our triangle over to what we just created. and let it chug. Yes, we don't care about the astrometric solution because we're done with it for now. And we don't need this anymore because that's the last time we're going to use it. Everything is going to be on each individual image from now on. And I will be right back because I need to check on my barbecue. Okay, I just got back from barbecuing and somebody decided that she was going to take my seat. Right, Luna? Is this your seat now? Oh, kitty. I may be biased, but I think she's absolutely adorable. Would you like to say hello, Luna? Yes? Not so much? Okay. Alright, so the next step will be to blur exterminator in full mode now, both our RGB and luminance images. Open up blur exterminator, let's try 0.6. And actually I want to do this on the luminance first. That's the more important for this particular operation. Don't need to run it in preview mode because this is so fast with hardware acceleration that it may as well be the same speed. That's nice. I think we could go with a little more. Let's undo that. And you know what? Let's just bump it all the way up. Normally I wouldn't recommend this, but in this case it might actually be good. Okay, I like it. Works for me. Most of the time that's not advisable to do, but this time I think it works. Do the same thing to the RGB image, and since we're doing that, that makes the container completely useless now, but that's fine. You guys got to see how to do that modification. Alright, so redo, I don't see any strange effects. Let's zoom out a bit. Look at this little baby galaxy. Thing down over there. Anything weird? No, actually looks considerably better. Okay, that step's done. Alright, so I'm going to reset the screen stretch on this, and I'm going to use Bill Blanchin's HT stretch linked RGB. This is my preferred stretch if I don't want to take the time to do generalized hyperbolic stretch. And since this is just color information, this is not the intensity or brightness in this image will not become a part of the final product. It doesn't matter. We're just looking at this to be able to visualize the colors and manipulate the colors. That's all we're doing here. Now, normally I take the stars out before I do noise exterminator, but I think this time I will do it ahead of time. And we're going to do it at full strength because this is color data. We want our colors to be as clean as possible, especially when we're adjusting our saturation. You do not want to use full strength noise exterminator on your luminance image. That's bad because then it makes it look plasticky and fake. But again, the intensity of this image will not cross over to the final one, only the color data will. And so this fine speckled noise in here, which will get rid of some of it, in fact most of it, but not all, it will come out in the final image. In fact, let me just give you an example. So let's compare this exact same spot on our color image. There's basically no noise here. There's a ton of noise here. We completely killed it. So if we go and do our L addition, it's going to look black because of the fact that we haven't stretched it yet, but oh, that looks stupid. Hang on a second. Let me reset this. We need to do a similar stretch to the luminance data before we can actually play, because otherwise it's going to look ridiculous. And then, okay, now we can do the L addition. And see, our noise is back. So you don't have to worry about overdoing the noise exterminator step on your luminance, or sorry, your color data, because your luminance is actually going to what it's I can't even talk right now. Your luminance is what's going to determine the noise in your final product. So it's perfectly fine to run a maximum noise exterminator on your color data. It's okay. I'm going to reset this and undo the pixel math for now. All right, going back to our color data, we can minimize this for now. That's fine. All right, so we've got noise exterminator taken care of. We're going to do a star exterminator, keeping the stars. This is a nonlinear mode, so we want to have unscreened stars turned on. And all this information is right here in the pop-ups if you hover over them for long enough. And we also want to keep our stars. So we'll go ahead and do this. Oh, somebody's home. Hang on a minute, guys. Alrighty, dinner's ready and kitties are fed. So let's have a look and see what happens. So we go in here, we look at our galaxy, all the stars are removed, and oh, what happened? Our hydrogen alpha has disappeared. Where'd it go? Well, I'll tell you where it went. It went right here into the stars image. So Star Exterminator still has problems differentiating between galactic hydrogen alpha sources, nebulas, that kind of thing, and stars. And also did rip out the blue giants out of M51, which it's supposed to do that. I just find it impressive that those stars are bright enough from that distance that they are actually visible individually. That's pretty cool. So there's a couple of ways you can approach this. One is that you can just simply process this as is. You can go and do some saturation passes on this, do some blue, do some max, probably do 2 blues, like that. Is that too much? No. Let's have a look at some other stars. That's probably okay. I'm just doing this roughly right now because I'm not going to keep it. And that might work. And then you could add it back into your image and it might be perfectly fine. But if you want to be a little more precise with how you're balancing the appearance of your hydrogen alpha regions with the rest of the galaxy, then you're going to have to do something different. Actually, we can just get rid of this entirely because we're not keeping it. So undo star exterminator. And we're going to go over here to script, utilities, game script. And if you don't have this, I highly recommend getting it because sometimes there's really just no other reasonable way to do the things that you want to do with this script. Most of the time when you're using a game script, you're going to do a gradient mask. That's going to be for something like LHE, HDRMT, things of that nature, where you want to have sort of a feathered or gradient effect between the area of your image where you're applying the effect and then the rest of the image. You don't want to have a jarring transition between the two that's obvious. But in this case, we actually do want a binary mask because we either want to pull the stars out or we don't. In the galaxy, we do not, and everywhere else we do. So we're going to add an ellipsoid, set a rotation here. In a bit, you can do that with the scroll wheel on your mouse for this particular script. And we got our furthest hydrogen alpha is over here. The one is right there. So we're going to have to move this up just a little bit. And just under there. Back over here. Good enough. Bring it in a little bit and then move it over. Like so. And you also want to try not to get any of your brighter stars on the boundary of this mask because then you'll have half a star left and then one half of the star will look different than the other depending on what you do to the image. All right, looks good. Get me out of the way. Okay. going to change this identifier to saturation mask. Apply this to the image, and we actually do not want to remove these stars, so we're going to hit Control-Shift-I to invert, and then we're going to do Star Exterminator again. And my headset likes to turn itself off on a routine basis, which is annoying. So we're going to remove the mask, and then we have all the rest of our stars removed except for the ones in the galaxy. And of course, we have our hydrogen alpha in M51 preserved actually with the subject instead of being torn out. And now you can actually freely see some of the other little mini galaxies in the area, which I think is kind of cool. That was kind of interesting. All right, so now we can deal with the stars, and this is usually pretty simple. I usually do one pass of maximum saturation, and then 1 or 2 passes of blue saturation. And these are presets I have set up, but they're quite easy to make. Let's see, do we need any more blue? No. And here's one of those weird spots like I was telling you here just a second ago, but I don't think anybody's going to notice that, so it'll be fine. It's just a tiny little detail. All right, so RGB stars are done. All right, so let's see. Next thing, we want a range mask. And this is just so that when we do our saturation adjustment to the subject, we're only doing it to the subject. We have heavily noise removed the background, but there is a little bit of residual color here, and we do not want to increase the saturation of this. We want it to remain kind of a nice neutral gray. Hit preview. You know what, that default setting, I'm okay with that. I like it. So we're gonna hit OK. And then close out of our preview. We're gonna hit it with a couple of rounds of mask blur, like so, and apply it to the image. Minimize it. Actually, we're gonna make this, we're gonna call this, range mask is fine. That's okay. I wanna not be looking at this mask. I'm gonna hit Control K. Helps if you have it selected. And then go ahead and start doing saturation. I think I'll start off with a max saturation pass just right out of the gate. I think that looks good. Now, let's suppose you want to do that for a second. Let's say you want to selectively change the saturation of your hydrogen alpha. I do have a preset set up for that, but let's say that you don't have any of these buttons set up. How would you create it, or how would you do it on your own? Go zoom into one of your areas of hydrogen alpha. Open up your base saturation tool. Left click and hold, and see what region the hydrogen alpha is on your saturation. All right, let's move this spectrum over a little bit so that way you can put it more in the middle. And it's sitting right in the reds, just like we expect. So we go over and find that same spot, click to add a control point, add a couple of control points on the other side. Since hydrogen alpha is a fairly narrow band, we don't really need a whole bunch of, we don't need it to be very wide. We're going to put more control points here and here, so that way the other colors don't get decreased as we're bringing this one up. And start bringing it up. Of course, it helps if you turn on the preview. Zoom in on this. so. If you want to be really nitpicky, you can adjust these one by one. Or change this to 0, 0. That's the one that we're using. 0, 0, and did I not take? Not. Enter. Enter. That's the one we're working on. 0, enter. Learn something new about this every time. 0, enter. And that one's already zeroed out, so we're okay. All right, get me out of the way. Back off on our preview, and then maybe take a wider view, and then turn the preview off, and then on. So, and now we've selectively enhanced our hydrogen alpha, and it does appear that there is hydrogen alpha emission even in the dust lanes. That is hard to see unless you actually selectively enhance it, but it is there even when we don't have that saturation boost turned on. That's how you would handle it if you want to do those separately. However, I'm not going to do that with this particular image because I don't feel like it needs it. And we'll go back and do our max saturation. Oh, that's a preview. Silly. Max saturation. I think the blue could use a little bit of an increase. It's probably about right. You will lose a little bit of your saturation when you add the luminance, so it's better to go a little bit too far than not far enough, because if you lose too much of your saturation, then it becomes very difficult to bring it back later on. All right. And let's do some saturation on this core area. It's a little weak in comparison to the rest of it. Looks like we're not quite on target. Shift this over a bit so it becomes easier to hone in on. Reset everything. All right, there we go. It's right about there. A little bit wider because this is a much wider color range that we're dealing with here. We are boosting the dust lanes quite a bit here. That'll get addressed with the local histogram equalization a bit later, so we don't have to necessarily worry about that right now. All right, that's not too bad. Let's mask. Okay, and we're gonna check our color balance in the background. And the way that we would normally correct that was with a histogram transformation. However, this data here, if you look, it's pretty darn close to color balance, but we'll go ahead and have a look at it anyway. So we go to histogram, hit the check mark to link it to the active image, turn on the preview, We're going to look at an area that's kind of in between the subject and the background. We're going to hone in on this background a bit, and let's go to green and start dragging up the blacks. Immediately it starts turning magenta. If we bring it back down, it was like, oh, you know what? Actually, it was very, very slightly green, maybe. What happens if we go to red and do the same thing? Starts turning blue, blue, starts turning green. Just a tiny little bit of reduction in the shadows on the green. And apply that, close that, get out of the preview, and then undo, redo. It's very subtle, but it has gotten rid of it just ever so slightly green. It's even maybe arguably slightly magenta right now, but that's better than green. Okay, we need to combine our stars back with our RGB image. Starless stars. And these are just scripts that are set up. There's nothing fancy here. It's just basically saying turn the target into, make a clone of the target that's called starless. Starless 1, stars. And then we just simply rescreen and replace the image, and we have our stars back. We're going to do a star reduction step, and the script for this, I never bothered actually making them all, or having them all use the same name. You could definitely do that. Clone for starless, now it's called starless instead of starless 1. And then we're going to use Bill Blanchin's star reduction method 3. Just to get just a little bit of subtle star reduction on that. Not too much. Some people like more than that, but I think that looks good. Don't need starless anymore. Minimize these stars. We actually don't need this either. We can just shade this down and bring it over next to its stars. Time to move on to luminance. So we're going to do an HT stretch unlinked. Again, this is Bill Blanchin's. And then we're going to do a star exterminator and keep the stars. But first, we need the exact same, binary mask. Actually, I called that the wrong thing, didn't I? This should actually be called star exterminator mask. But that's what happens sometimes. It's okay. Control-Shift-I to invert. Move the stars, but we keep them. Move the mask from this. Moved. Minimize. Up here, and then we're gonna undo the stretch as well, and we need to play that, and then we're gonna put this mask back on. We went back enough steps to where we weren't using the mask, and Pixinsight will automatically remove the mask if you go back to a step before where you applied it. So put that back on there, reapply the invert, Control-Shift-I, and then this time we're going to do the linear star exterminator and not keep the stars. Why do I do this? I do this because I like the way the stars look when you use the HT stretch from Bill Blanchin better than the generalized hyperbolic stretch. I don't like the way those stars look. I like these stars from Bill Blanchin's stretch much better. All right, mask, remove, and then we can reset our screen stretch. Yep, and reapply it. And now we're going to go to generalized hyperbolic stretch. And we're going to pick a spot where we're just on the border between the information that's well displayed and not, which is in this case right about here. So this is extremely well exposed. This is just background noise. So somewhere in here, something like that, send it to symmetry point, zoom out, reset our screen stretch, turn on our preview, max out local intensity all the way up to 15 and start bringing the stretch factor up. And we want to bring it up just until we start to see the faintest stuff in the image that we want to display. Not necessarily what's there, but the faintest stuff that we want to display. Then with the highest sensitivity option turned on, adjust the slider until the contrast is maximized, which is right about here. Apply it, reset the tool, and now all of our data is way above the black point. There's this big gap here, so we need to fix that. We go to linear, you can click on here, or you can use the slider right about here, send this to black point. We don't have any low clipping, so we should be good. But I'm going to turn off use highest sensitivity and just start bumping that up a bit. Come on. And we're already starting to get, so I was pretty close already. Just get that to where we don't have any low clip at all. Apply, reset. I'm going to use a local intensity of 5 on this step. I'm going to click right near the peak, send that to symmetry point, and then start stretching again. Alrighty, that looks about right. We're going to once again try to maximize our contrast. That's about right. And make sure that the center is not getting above 0.8. In fact, it is. So we need to back this off just a little bit, maybe take this down to 0.5. Because if a value, if the K value, which basically stands for the intensity, goes above 0.8, then the color data will not be able to colorize the image. It'll become washed out. So that looks like that's as high as we're going to go. Hit go. And now we've got our stretch. Go ahead and close that up, generalized hyperbolic. All right, next step. That looks pretty nice, actually. All right, next step is going to be to do some local histogram equalization. Turn on the preview, and that is way too much. That's crazy. We don't want to do that. Actually, get right in on here. So I usually do increments of, or multiples of 2 rather. So 8, oops, I won't let you do 8, the lowest is 16, sorry. Come on, 16. Oh. All right, that's a little bit too fine scaled, about 32. That's about right. What we want to, at least what I want to enhance are these dust lanes. I want these to become more enhanced. That's what I was talking about earlier, that we were going to fix the fact that the dust lane saturation was getting a little bit overdone and over brightened. We can darken those back down with local histogram equalization. Also, we're just enhancing the contrast in the image overall. About 64. Now it's starting to enhance the spiral arms more, which isn't necessarily what we want. So 32 is the correct amount. And basically, if you don't know what this tool does, the number, the smaller it is, the smaller the scale of the features that you're going to enhance in this image. So the little tiny fine-grained detailed stuff, that would be a lower number. If you want to just enhance the overall structure of the whole image, then you would be using something larger, like 128 or even 256. But this amount is way too much. I'm going to turn this down to 0.4 and hit the preview. All right, get me out of the way. Get out of the zoom in. Back off a little bit more. And Actually, I'm curious what's going on over here. That's okay. That actually is detail that is there. I just hadn't noticed it before, so that's perfectly fine. Apply. All right, let's bring our stars back in. So once again, we open this up. We do starless. Let's plop it right in front of my other image stars. Rescreen and replace. Get rid of the copy of the stars image. Minimize this one. Oh, whoops. Ah, there we go. This one. Actually, I closed the one that I wanted, but that's okay because we have the, wait, what? Oh, never mind. I'm going to clone this, close this, and then apply the exact same star reduction method that we did earlier, which is version 3 or method 3. Close that out. And then here comes the moment of truth where we recombine the luminance with the RGB. Okay, so we did lose a lot of our dynamic range, but we can adjust that. Well, though, I'm going to apply some saturation. And then a curve adjustment. Where do you live? You live right here. Okay. I do a gentle S-curve. Don't want to darken things up too much. We do want a little bit of gray in there. But we don't want things to be quite as flat looking. In fact, I realized that I got to do something. There's probably been somebody watching that's been screaming it for about the past 2 minutes. Where History Explorer comes into play. Drag this onto the desktop. Get out of there. Undo color saturation. Undo LRGB combination. And the thing that we forgot to do was the noise reduction. You go noise exterminator at 70%, which is usually the right amount for a luminance image, which is why I have it set that way. What do we got? Looks pretty good. Okay, we can close that out. Minimize this again, and then do the L addition. And because we saved these two process icons right here, we can just doink, doink, and we're right back where we were. So we didn't really lose any time at all. Still don't like how bright that is right in there. So what I think I'll do is something a little unorthodox because it is a mistake. I should go back and just correct that saturation adjustment, but I'm going to do something a little strange, and you'll see why here in just a minute. It's game. little bit wider. You usually want to be about twice the width of the area that you want to affect. This time it is going to be a gradient mask. Invert, Control-Shift-I. Visualization, just make sure I had the right bit. I have a process in here. Load History Explorer. Get me out of the way. I believe it was this one right here. Yes. You can do the exact same thing, but in reverse. But I'm not affecting the color of the core of these two galaxies because I masked them off. It's a little bit too far. Right about there looks kind of natural. Get right up in here on the affected areas. Go. But anything else that's getting affected by this? Yes, but it's not a problem. So I want this to be enhanced, but I don't really care about this area right here. That's fine. So then apply. Close that out. Get rid of our preview. Out of the way again. And just another subtle curve adjustment. Don't want to touch this stuff down here. If you want to lock this onto the original line, which is this diagonal line here, so you're not affecting it all, you just make your input and output values exactly the same. So 0 0.4, 0 0.4, 0 0.2, 0 0.2, and it will lock it to the vertical line, or sorry, the diagonal line, and that way you're not changing anything in that range. Where's all this stuff at? You know, I'm going to reset that. I don't like that at all. So to get the core regions bumped up just ever so slightly, you want that to move up. I think that looks a little bit more natural. Oh, go away. Yeah, I like it. Close that, and I think we have an acceptable result. Okay, are there any questions? Be sure to put them in the comments down below. If you have any suggestions for future videos, of course, put those in the comments as well. I do read all of them. Now, I am not a professional YouTuber, so sometimes it takes me a couple of weeks or even months, if I'm being really bad, to respond, but I will respond eventually, I promise.